Okay, hi, I'm John Layden, and I guess I'm here to do the debugging in Python lesson. So I have quite a bit of programming experience in lots of different languages, and have worked in programming, which is how I've come across debugging, but honestly, I don't use proper techniques as much as I should in my own life. So this is also to get me into the right practices myself. So yeah, starting off, all of the content for this lesson is up online. It will be available on the U of T Coders GitHub site. Right now it's on my own, which is J. Layden Study Group. And yeah, so debugging is more of an art form than anything else. And so while I can't teach you in 1 hour to be a master debugger, I can cover a bunch of the concepts and tools that you can use. And while this focuses on Python, similar tools are available in pretty much any language that you would use. So you can use, knowing the language and what tools are available and how they generally work will extend to other things as well. So I'm gonna basically split this into two sections: hunting for bugs, which is the testing, and actually finding the bugs in source code, which is the searching around for them. For testing, there's actually I came across a blog and podcast specifically about testing in Python. That's how important it is. And then for debugging, we've got Pdb, and it'll be I'll be showing that with an IDE. But anyway, to start back at what debugging is. I've got the Wikipedia definition here. Debugging is the process of finding and resolving defects that prevent correct operation of a computer software or system. So in reality, it's actually a really huge topic, and we're just going to focus on the basics of finding bugs. And I will talk a little bit about prevention here and there. There are certain practices you can do as you code to make it easier to find bugs and prevent bugs from coming up. So it generally goes in a cycle of testing for bugs, finding them, fixing them, testing again, finding them, fixing them. And I'm using a pretty general concept of test here, because at the basic, testing can just be running your program and making sure that it works. But then there are, of course, much more formal methods of testing it and how to make proper test suites that will run automatically on your code and highlight where there might be problems. So most of you will be used to using some kind of writing a program, and as you write it, you'll use the REPL. This is what you get when you just type in Python, the run and val print loop. I'm using the Spider IDE here. And so sometimes you might want to make sure that you understand how code works. So if I go print hi, then clearly I've been working in Python 2, and I need to change how I work with Python 3. I can also put in some code, and I've specifically got some errors in here so that they show up. So I wrote some code, and I get a syntax error. So I see that, and I fix it. So that was my test. The interpreter tells me where it is, and then I fix the bug, and then I test again. And I go through this loop over and over in a very interactive way. So this time it ran, and I should have a divide function, and I'll test that out. But then I get the wrong answer. 1 divided by 2 isn't 2, and I might try keep trying some more. 2 divided by 2 works. But if I do 4 divided by 2, I get 1/2. And so if you're paying attention, in my code, I had it backwards. And that's what's wrong. And so then after doing my tests, I find the bug, I fix it, and I try it again. Okay. So then if I divide 1/2, I get 1/2. So that's kind of the first level of debugging a lot of people do. It's called interactive debugging. And it's certainly useful in your quick development, but then you get to the problem with it is that you lose consistency and it's not automated. So every time you make a change, you've got to remember what to test and type it into the command line. If I change a function, if I changed my divide function so that that worked, what if I broke another test? And then even with tab completion and copy and paste, doing all of these tests becomes really repetitive, and through human just laziness, you end up not doing it. So then that's where unit tests come in. Yeah, that's, oh geez, I'm sorry. There we go. Yeah, so that's why we have unit tests. So unit tests are the smallest testable parts of a program, and the smallness of them is what makes them easier to automate and easier to debug as well. Python, like a good programming language, it actually has a module called unit test in its standard library, and it can handle that kind of workflow. I should also mention there are other unit testing frameworks. A rather good one is called PyTest, and there's also Nose, but they all work in the same kind of idea. So, as an example, and this is where it'll get more interactive again, let's make a function that is just going to do a little routine for us. So it's going to split a list in the middle and return a tuple containing the first half, the middle element, and the last half. I'm going to use a test-driven design style and create the test first. And so here we have the syntax for using unit test. This gets put into its own file. You have to import the module, and then you create a class that inherits the unit test class or test case class, and then you define a series of tests. So this one is just testing a simple case. We give it the string. There's a typo in this. I'm sorry, I'll go to my better code. Okay. So it tests a simple case. It runs the function splitter on 1, 2, 3, and then it compares it against the tuple, which is what we expect as output. A list, that's just one, then the middle element, and then the rest of the list. Okay. So if we were to run this, and then at the bottom of it, we have the standard if name equals main, then run unit test.main. That's a bit more boilerplate. That's so that if you run this as a script, it runs all the tests and gives you the results. So now that we have, is everyone up to speed here? Or everyone's following along? Okay, so if we take this program and run it, we're of course going to get an error. and the error is actually that splitter is not defined. So the other thing is we need to have a function definition in here. And so for now, I'm just going to return an empty tuple so that you can see it run without an error. In this case, I'm running the full script, but if I'll show you, I'll actually, the font size is a little small in this too. But and my console always takes a little long to boot up. Okay. Study group. Python debugging. Okay. Good. So if I was to run Python and test splitter.py, which is the name of the file, then it's going to come with this, give me that output. But I can also, there are a few other ways to run this. So we can also
ran 0 tests and things. And is there something that we're supposed to have after the class?
You have ran 0 tests?
It says ran 0 tests.
Because even when I was missing the function definition, it ran a test. Oh, so yeah, I guess I should explain. One of the most important details is that the functions need to start with this test underscore. Does it have that? It should work in Python too as well. So there are other ways of running it. So you can run it just as its standalone script. You can run it with the module unit test, and it will actually discover all of the tests in the current directory. Or you can tell it specifically which module to do with that style. So I go Python -n unit test test splitter. I still get it running one test. Fine. Okay. So it's still not working for you? Are you inheriting unit test.test case and everything? I can. Okay. Okay. So right. So we've run a unit test. And the value of it is it will run everything called test underscore and then something. And if a test fails, it tells us which test failed and how it failed. So here we get the it failed in test underscore simple case, and the problem was that the tuples differ. The empty tuple does not equal the expected thing. Okay. So we know that there's a problem, obviously, but before we actually write the function, let's come up with some more tests for it. Okay. So when making tests, so when making tests, you want to think of the a few examples of regular input that you would expect, but one of the most important things is to get all the edge cases. So for lists, you would want to test against an empty list, maybe a list with only one element in it, a list that had different numbers of items, different types inside of it, stuff like that. So let's create a new test. And so with what I just said, what's a good test to do? Okay, so we'll create a test that's called empty list. Okay, self. And now in unit test, they've got all of these different assert tuple equal, assert list equal, that kind of stuff. Because our function is just returning a tuple, all we need to worry about is the tuple equal. There is also an assert equal, but that doesn't necessarily go deeper in. Assert tuple equal is good because we know it's going to test that everything inside of the tuple works.
Is that what tuple means? Like, it's just zero?
Oh, yeah, so a tuple is like a couple, triple, quadruple. A tuple is a general combination.
You can have more than 5 items, so we have 3.
Yeah, so ours is a triple. It's a tuple with 3 elements. Yeah. So an empty list. Okay. And what do we think should be the result with an empty list? So this is where being really one of the things that you need to. An error might work, yeah, but then you also it's one of the cases where good specific design works. If I just said it gives you the first half, the last half, and the middle element, then that doesn't tell you what happens in empty lists. So an error might be good. I was thinking that we would give that the first half is an empty list, the last half is an empty list, and there's no middle element. Okay, but you could raise an error. So in that case, you would use self assert error or raises error. That's actually a good point. Assert is actually a statement in Python, and it's a concept that comes up in a lot of different languages. And it's basically a statement that checks if something is true, then you continue with the program. If something is false, you quit and raise an error. So it's a lot like saying raising an exception, except it's a specific programming concept. In Java, there are assert statements where you might have a case where there should be no instance where a negative number gets called to this function that you use just to count down positive numbers. And so you would put in something that says assert x is greater than x is greater than equal to 0. And then if your program, yeah, if it meets that condition, then something's wrong and your program quits.
Is there ever a statement you can add to it to say then skip this section, or it always just quits?
That's when you would use if, right? So that's when you would use branch. Assert statements are more for just this should never happen. Or raise it. It's a little like raising an error if the file doesn't exist, but it's for more extreme cases. So as you can see, assert is actually its own statement in Python. You can put it in your own programs or whatever. And so the unit tests just bring in that terminology. Okay, so then we've got an empty list. We might try a list of length 1. And it's good to use descriptive names, but sometimes coming up with good descriptive names is the hardest part of programming. So splitter. And so the important thing with this test case is that it's a single element list. So I might just put in whatever I want inside the list. As you're making the test cases, you want to think about what's the particular thing you're testing and what you're not testing. So in this case, I'm thinking the first half is empty, the last half is empty, but the middle is A. Okay, so can you think of other cases? Yeah, that could be relevant too. You are allowed mixed type in Python lists, right? I always forget. Some programming languages don't let you do that. And an empty list there. Now, when you're doing your tests, sometimes you'll make a mistake in your tests. So for instance, in this case, I have to be careful that one is a list containing the empty list. And that would be an easy thing to miss. There's one really important one in here. We've got odd length lists, and we've got the empty list, but we don't have an even length list. Okay. Assert tuple equal. Okay. 2 and 4. So the first one is obviously 2. The last one is obviously a list with 4 in it. And then I'm going to say following the whole there's no middle entry thing, I'm going to say it's not. Okay. So this is maybe a weird function on its own, but so as you can see in this case, our tests actually define what the function should do. We know that if it's an empty list, it should give us this output. If it's in most cases, it should give us an output like the first one. We might even make this one longer. In most cases, it should give us something like that. And then if it should work no matter what types are inside of it. And if it's an even list, we should get none as the middle element, but still the first and last half. Okay, And so now that the tests are done, we can run it, and we failed 5 tests in 0.019 seconds, which is what we'd expect because our function doesn't do anything. Okay. So I'm just for the sake of time, I'm going to copy over one of them that definition that kind of works. So so if we were to work together, we'd probably come up with something like this as a first try, right? We have we find out the length of the list. We divide it by 2. We take the first half of the list, which is sliced until the halfway point. We get the middle element of the list, which is just, and then we take the last half of the list. Okay. And if I run that, then I did 5 tests, but I failed 1 and I got an error in 1. So let's see what failed and how we can fix it. So this is showing you the way unit tests can be used to debug now. So the first failure, or the error that happened, was we got a list index out of range. Right? There is an index error when testing empty list. Okay, so if I look over here at the function, I can look at this statement and say, well, the index error was because I'm telling it to look at 0 plus 1, and that's not an index in the list. Right? So then an easy way to deal with those extreme cases is you put in your if statement, length equals 0, return none. There. Okay. And then I run it again. So this time, and because I didn't try fixing the other error, we wouldn't expect it to be, or the other failed test, we wouldn't expect it to work. But this time we don't get the original error, and we see an assertion error. The tuples differ, and so this gives what we are worried about with the, and if I scroll up a little more, there, it happens during the even length. And so then that tells me that I should probably have, if the length mod 2 equals 0, x length 2, none, and x 2 colon. Yeah, so the assertion, what happened, it actually goes into more detail, which is the nice thing about these assertion errors. So the full message is assertion error, tuples differ. So we put in, or this is the result of the function, a list containing 2, 4, and then the empty list, but we expected to get 2, none, and the empty list. And so then it goes into more detail. It tells you the first differing element was 1, which, because Python index is at 0, is the second element in the list. And it got 4, and it was expecting none, and then it shows it in a third way. So a lot of that information is redundant, but some cases it might give you more or less information. So in this case, if I'm looking at this, I'm thinking, well, the first element worked. So if I look at the first statement, I should keep that first element. Now the second element should be none. So I'll make that special case that it's none. And then the last element is this, is what I should have got, what I ended up with here. So I'll just put it like that. I'll take this thing and put it here, and then all the rest, right? So that's kind of the power of unit tests, is if you break your code apart into these individual units and functions, you don't need to put print statements anywhere because you run your unit test and it gives you all of this detailed output about what went wrong. And so then now it's run the 5 tests and they've all worked. Yeah. So this unit tests are something that you should always do, but in reality we rarely do because we're just working quickly and want to get the actual code out. But what I found interesting is even as I made up that example myself, the results actually looked nothing like I expected as a first rendition. Okay.
So what do we do is instead of just building all of those into the function every time, you know the test generated, you just make you know what you tested and passed. Or other people use it and
yeah, so they get their most use when you start, if you're going to be using and modifying this program more in the future, and especially if other people are going to be using and modifying it. So what often happens is you create a Git hook so that every time you do a pull request, it runs the full test suite to make sure that you didn't do anything in this section of code that screwed up a test in another section of code. So for more software engineer kind of, our software needs to work all of the time, people will often do that to make those assurances. So there are people whose job is to write these test suites. That's all they do. They work closely with the coders and the software architects and do this. If you have a test suite, it's a good way of seeing if a program is good, if it's got some form of testing involved. But then it's kind of a preemptive thing, really. So this is the almost prevention. Yeah, that's the main difference, is that it's operated. That's right. Yeah, and I should also say that if I had this in another thing, then I would use import, or I could use from this. If it's in another module, the test would still be in a separate file, but I could load them it that way.
Does Python have a way to just go through line by line code? Or do you have to?
It does, and so we're going to do that next, actually. Yeah. Yeah. So yeah, that's kind of the prevention and thorough testing aspect of debugging. The other thing that we run into, which is you're using print statements all the time, and this is probably what more people expected, sorry, is the finding the bugs. So I talked a bit about stack traces. We've already seen a bunch of stack traces, even in this one. But the main thing with it is it shows, no, that's there. This will show it. So a stack trace the last line is always the error. Sometimes the error message, like a syntax error, will have a little more detail, and then it tells you what file it happens in and the actual, or it tells you what file it happens in and what line in the file, so where it is. That's something that you're probably already familiar with. Print debugging is the other thing you're probably also familiar with. So yeah, as my example for this, I've got this average function. So there. And done right. So if I just take the average of 1, I get 0. If I take the average of 1, 1, 1, I'm getting 2/3, right? So, and print debugging and all that kind of stuff is definitely something, even with tests, you'll need once the functions get longer. I can't really break down average into smaller parts effectively. It's a little wasteful. And so classic print debugging, you would probably put in something here like print accumulator or back. Right, and then if I put in the new definition, and this thing cooperates with me, right there you see the advantage of test. Then now it prints it, and so I can see that, well, that part's behaving right. And then you end up filling your code with those statements. So that's a pain, but also there's a tendency to leave print statements inside and forget about them and stuff like that. So Pdb, Python Debugger, it's a much more sophisticated way than print. And when you use Pdb, the execution is interrupted, and we can check the value of variables whenever we want to. It just breaks out the lines. So I'm going to modify this a little bit, this file, so that it's just the function. The other thing that happens is if you if you print stuff inside of unit tests, then the output gets all garbled up and doesn't work. So here, the way you would do it in command line is you import pdb, and then wherever you want to stop and start stepping through, you put in pdb dot set underscore trace. Okay. And so now if I run this, in the command line, sorry, I need to actually call the function. So as you can see, it doesn't actually stop it if you never hit that point in the code. There. So now if I run it, and it stops it and gives me a command prompt pdb. It should also work if I do this here. Yeah. So it stops it. In this case, it tells me where I am. I'm about to run line 7. And then it gives me this command prompt. Because this is IPython, it's IPDB. And so if I want to do any variable introspection, I can press P and then the variable name. Okay, and we're back. There we go. Okay, so sorry for that interruption. I should have run to get my code earlier. So yes, when you use the Pdb set trace function, it stops execution and keeps track of where you are in the code. And then it gives you a command prompt, a lot like the Python command prompt, so you can interact with your code. So here the P statement prints. So I printed ACK, and I saw that it was 0. I can also print length and see that the length is 4, which makes sense because I called it with 1, 1, 1, 1, 1. Right? And then to step forward, that's the N command. Can you guys see that okay? It's unfortunately stuck at the bottom of the screen. To step forward, it's the N command. To, if I put in C, it will just continue execution. And then I can also run any Python code that I want by prefacing it with an exclamation point. So that's another way that you can print output. You can even change what things are. So, this works no matter what. So going to the next line, I'm now in the loop, and I can see this. And then in this IDE, there's actually a variable explorer so that I can see what the values of the different things are, go through it that way. Right. So if I, also I'm going to point out that this is not how you should write that function. You should use for x in the list and add it up. But if I run it again and it breaks, the arrow here points to the next line that's going to run. So that hasn't run yet. So if I go next, then I'm on this line and I can see what the value of I is, and the value of I is 1. And if you're astute, that's the actual bug, right? Because since Python indexes at 0, the bug is that it's starting at 1, not 0, right? And so then I might try now to, if this is just in debugging mode, I can interact with it. So I can say C equals 1, or sorry, I equals 1, 0. And so now I've set I to be 0. Good. And then I'll go to the next one. And we're back at the loop statement. We're inside the loop, so let's print I. And we see that because of the way Python for loops work, it went to 2 again. It doesn't actually, it has a set list that it goes through. So we can't fix it in the middle of the debugger, but we can see that it went wrong like that. Run it, continue, and we get the right value. Right? And there, oh, yes, there probably is. What's the? Oh, that's right. It will round it down. Yeah. Yeah. So one of the reasons I like Python 3.
Why does it not? I understand that. I guess Python's strength at 0, that it indexes at 0. But what if you did actually just mod the average of the last? You want to skip the first one. why doesn't it run that one?
Oh, so if you wanted to skip the first one on purpose, and that was what the function did, then the function worked.
Okay.
Yeah. But in our case, we wanted the average of everything. And if we set up our test suite, then we would keep getting these errors, and then we'd be able to assess it. And in the case of our test suite, it probably wouldn't fail on a couple of them, but it would fail on the default or the expected cases. So that is how you do it in command line. I should also show that most IDEs will have a debug menu in it. So if I reintroduce my bug, and here, and remove the PDB stuff. Under the hood, this IDE spider uses PDB to do it, and several other IDEs probably do as well. But I can run that code, and then check average of an empty list as division by 0 error. And average of 1 and 1 should not be 1/2. So we're now back at the point where this is the code. If I go into debug, I can set and clear breakpoints. So the breakpoint is that set trace statement essentially. But I can put this in with the IDE without messing up my code at all. So if I want to set a breakpoint here, I go debug, breakpoints, set breakpoint, and I just put in something to call that function. Okay, and then I can go and run debug. And same thing happens, it stops it. It tells me where I am, and I can interact with it the same way because this is using PDB under the hood. But I can also go into debug. We've got step into, step return, continue, and exit. Okay, so I'm going to stop it, and instead I'm going to put a breakpoint here so I can show you the step into. In this case, breakpoints have to be on actual statements. So I can debug. Let's remove this breakpoint. Where's my F12 button? There. Okay. And debug. Keeps wanting to debug at the same spot every time. That's annoying. Anyway, there we are. Okay. So, yeah, it stopped it at the actual function definition. Okay, so that's one way that it's different.
Like you ran it with a break, and then if it runs successfully, that's when you run it.
So the break is always just going to stop execution in a similar way to that set trace function. But in this case, I didn't run into this before with this IDE, but in this case, it's actually, if I press debug, It's actually stopping it at the definition itself.
Would it stop earlier if there wasn't one?
No, yeah, programs don't know if you do have a bug. The breakpoint just tells it stop doing what you're doing. So in this case, it's first stopping as it's reading the file, or in these breakpoints, it reads the file down. So anyway, we get to this x equals 0. I can go next, and here my next thing is a function call. If I just went next, let's remove that breakpoint. This is when I go off or screw up because I went off script. Okay. So I want to show you step into. So we've stopped all execution, removed all breakpoints except for this one here. So we're at this x equals 0 line. We go next. And then if I know that the bug is inside of average, or I want to go inside of average, if I was to do n, it will just skip the function, right? It's supposed to just skip the function. I hate it when things don't work right in demos. The next line isn't supposed to go into the function. So let's try it again using the actual tools here. So we run the current line, run current line, and then it should have just stopped here. There, then it stopped. Okay, good. It's misbehaving a little bit, but so the default behavior for just running the next line is to debug. Well, that's annoying. Sorry. Let's see. Spider. Yeah, so if you always stepped into stuff, then you might have a case where you're just calling a regular Python function like print, and then it would go into the function print and then step through the different lines in print, and that would be annoying. So the default behavior for the running the next line, none type has no attribute. Execute. That is weird. Okay, let's try this again. Okay, so the default is to just step over stuff because you don't want to go into the system calls and stuff like that. And so in that case, it actually worked like it's supposed to. I think didn't. Well, my installation broke. Yeah, so not that one, that one. So yes, the default behavior is for it to just run the line without going into the code, and that's because some cases you don't want to go into predefined functions and run them. If you do want to step into the function to call, in PDB it's S. In an IDE there will be a step into, and that will go into the function call. Okay. I think now that my computer has finally called it quits, that's probably a decent place to stop. There is another section, or there is another problem with using print for debugging though, which I'll just talk about quickly to finish up, and that is you might you might forget to remove the print statements, and so then your user gets all of these print statements with information they don't want. So there's a module, it's the logging module in Python, and you can use functions like logging.debug, logging.info, logging.warning. It's very well documented with a tutorial and everything. And the nice thing about logging is that you can actually tell it to print statements to a file or anything like that. So if you want just the output to go printed to the screen, and then you want all of the warnings and errors and stuff like that to go into a file, you should use logging to do that. And it will actually preface everything with, yeah. So here's a sample of the default output. It will say what the message is and what the level of the message is and stuff like that. That wasn't the button I wanted. And then finally, most software things you can report bugs. GitHub has an issue tracker, which is a basic bug tracker system as well. So if you come across anything in an open source project you're using, it's a good idea to report bugs. And as you get more experienced with debugging, you'll have a better and better idea of what should go into the bug report. So I think that's it. Hopefully you learned a bit about the tools and good practices. And I hope that you do end up using some unit tests in the future, as I will.
Is there one tool that you prefer?
Yeah, so in terms of preference, I would use PyTest for the unit testing, and for debugging, I still end up using a lot of print statements. And there is actually one big reason for the print statements, and that's if I had for I in range. I had a program that was running this long thing, and then it had some long function call. Sometimes you just might not even know that it's running. And so one of the most common debug things that I do is just this. It prints what loop iteration I'm on, and then I know if my code is still running. Yeah. That has actually helped me a lot in the past when sometimes, like, I might get a case with, this could also come up with this is a common thing that you'll do with count This is a common thing you'll do where you have some kind of end condition on your loop. And if you just put in an iterator that tells you how many iterations you've done, it'll tell you when. If I did this with PDB, then every loop iteration I would have to sit there and tell it, okay, continue. Any other questions? No? Okay, well, thanks. I'll stop the hangout, or you can.